Hello students, I am Professor Prakash Naik, HOD of BC Department and Human Institute of Management and Computer Application Medical. In the last video, we had learnt Introduction to Linked List. In today's video, we will be learning about advantages, disadvantages and difference between the arrays and linked list. So the topics that we are going to cover is advantage of linked list, disadvantage of linked list, difference between arrays and linked list. So this will be a 10 to 15 minutes video. So let me start. Now, what are the advantages of linked list? We know that linked list is a dynamic data structure. So the first advantage is linked lists are dynamic data structures. What do you mean by dynamic data structure? That means the data structure that is created at runtime. The advantage of this dynamic data structure is that the size goes on increasing or the size goes on decreasing depending upon the user requirement. They increase in size, at the same time they decrease in size. The second advantage is that linked lists have an efficient memory utilization. That means how much memory is required, only that much memory can be specified to it. In case of arrays, we had one disadvantage that the size of an array was declared at a coding time, that is during the compile time, because of which lot of memory is wasted. But here there is no question of wastage of memory. Why? Because at one time one node has been created. So one more time, if you want to add another data, you will create one more node. Like this, any number of nodes can be created. Here memory is not pre-allocated. Means what? It is not initially allocated. It is allocated when the requirement exists. Memory is allocated when it is required and is deallocated when it is no longer needed. Now the third advantage is that insertion and deletion are easy and efficient. Easily the nodes can be inserted and easily the nodes can be deleted. It can be inserted in a specific position, either in the beginning of the linked list or end of the linked list or in between the linked list. Many complex applications can be carried out with the help of linked list. Now let us come to disadvantages. Now, as we have seen the node, there are two parts in a node. One is the data and one is the link. The data contains 4 bytes. At the same time, the link also contains 4 bytes. This means every node occupies 8 bytes. Thus, we say that it consumes more space because every node requires an additional pointer to store the address of the next node. Further, if you want to search a particular element, it is very time consuming because it searches for the first node till the specific node. We cannot directly search a node randomly. This is one of the disadvantages of using a linked list. Now, what is the difference between arrays and linked list? The first is the size of an array is fixed. That means during compile time, the size is given. During that time, we don't know how many elements we are going to input. So we will give the maximum size in the array. So the size is fixed. In the linked list, the size is not fixed because every time we will be inserting one node at one time. As one node is created, memory is allocated to one particular node. So how much nodes are required? Only that much nodes have been created. So because of which the size is not fixed. The size goes on increasing depending upon the requirement. The second difference is that in arrays, the memory is allocated from the stack, whereas in the linked list, the memory is allocated from the heap. The third difference is that the arrays occupies less memory than the linked list for the same number of elements, whereas in the linked list occupies more memory. So why it occupies more memory? Because linked list has two parts, one is the data and one is the link. Because of it occupies more space. The fourth difference is that the total number of elements in an array needs to be specified during declaration at compile time. How much elements you need, maximum how much elements you need, that is specified in array. But in linked list, you need not specify at a compile time. Only during the runtime, what happens is the specific locations will be created. In arrays, inserting a new node at a front is difficult because existing element needs to be shifted in order to make a room. For example, I have input 5 elements and now the sixth element I want to input the first position. That means the first element should be shifted to the second position, the second to the third, third to the fourth, fourth to fifth, fifth to the sixth, and in the first position the new element needs to be inserted. But in case of a linked list, inserting a new element at any position can be carried out easily. In arrays, deleting an element is not possible. We cannot permanently delete a particular element. In linked list, deletion is easily performed. As a particular node has been deleted, the next node occupies the current position. The next node will occupy the current position. Further, in case of an arrays, traversing is performed with the help of array index. That is what? Arrays are having index from 0, 1, 2, 3, 4, so on. So to traverse from one element to other element, we have to increase the index value by specifying within a loop. But in case of a linked list, traversing is performed with the help of pointers. So what we do is we define a pointer, and what is the pointer? Pointer is the address of the next location. Pointer is an address of the next location. So for traversing it, what we do is we use the pointer, or we use the link. And using the link, what we do is we can traverse from one node to the